All right, so now that we have worked with hexagons, regular hexagons, so we're still working with these notes right here, and today you will definitely need a calculator. We are going to focus in on some other polygons other than hexagons. So we're going to change the number of sides. Okay, so on the second one here, we're still finding the area of a regular polygon, but we're going to change it to a regular pentagon. So a pentagon has 5 sides with a side length of 8. Okay. So here I'm going to have to just do some sketching. Okay, so here I'm going to do a pentagon. The number of sides is 5. Okay, so I'm going to do my best, and this is why I use pencil, to sketch kind of a regular pentagon. So I'm trying to make all the sides and angles congruent. Okay, now I may not be doing it totally accurately, but I'm getting the right idea. Okay, so here's a 5-sided figure. Hopefully all of those sides and angles are the same. Now what we're going to do is from the center point, we're going to break that into triangles. So again, I'm just breaking it into triangles here, and instead of 6 triangles, I now have 5 triangles. But all of the triangles are congruent. So if I drew this perfectly, which I did not, but if I drew that perfectly, then all 5 of those triangles would be the same. Okay, so here they tell us that the side length is 8. Okay, so here I have a pentagon. This side length right here is 8. All right, so what I'm going to do is same thing I did last time. So the first thing I'm going to do is I'm going to draw the triangle. Okay, so I'm going to take this triangle. Okay, here I have a side length of 8. Okay, I'm going to move it down a little because we know we break it in half, right? So I'm going to just move it down a little bit. And I need to draw in the height. Well, I'll do the central angle first. We'll do the central angle, then we'll draw in the height. Okay, so 2, we're going to find the central angle, which is always 360 divided by n. But in this case, it would be 360 divided by 5. Okay, so I'm going to take my calculator and do 360 divided by 5. And I get 72 degrees. Okay, so I get that my central angle here, so the central angle here, which is also here, is, oh, I said 72. I wrote 70. I'm not sure why I did that. Okay, so here is 72 degrees. So this angle right here is 72. All right. Now, what happens is, remember, I have to draw in the height of that triangle. I have to find the area of this triangle, which means I need to know the base, which is 8, and the height, which is what we call the apothem. Okay. So here I don't know what that is, but I'm going to use that right triangle to help me. Okay, so I'm going to take half of 72 for this angle up here. Half of 72 is 36. Okay, so now I have this right triangle here. I'm just going to highlight that part. I guess I'll highlight it in a different color. Okay, so I'm just going to highlight this one. This is going to help me solve for what I need. Okay, so here's that right triangle. Now let's look at the formula to see what we even need. Maybe you know already, but I want to give you a process. Okay, so area is 1/2 ASN. I'm going to highlight what I know already and what I need to solve. Okay, so 1/2 I obviously know. A, I don't know. Okay, so remember this is the apothem. I don't know what that is. Okay, I know the side length and I know the number of sides. So I have to solve for A. Okay, so that's what I need to solve for first. And I'm going to use this little right triangle to help me. Okay, for the right triangle, if this whole side length is 8, then this is 4. So I have this right triangle right here that's 36 degrees, a right angle, and this side length is 4, and I have to solve for this. So it is not a 30, 60, 90. So here's where I need to use trig. And I apologize that these notes are not very big. I don't know why I made them so small. But what I'm going to do is I'm going to use a Post-it note. So you can use a Post-it note, or maybe just like on a page in your notebook, you can continue this. What I'm going to do is I'm going to draw that triangle and remind you how we can use our information from Unit 8 to help us. Okay, So I'm just drawing this one shaded pink triangle. I'll shade it pink here so you know it's the same. Okay, I know that this angle is 36. Okay, this is 90. I know this is 4, and I'm solving for this side length right here. Okay. Now, because it's not a 30, 60, 90, I have to use trig. So with trig, the first thing you always do is label your sides with H, O, and A. Okay, so across from the right angle, that's H. Okay, across from the angle, so opposite of the angle, that's O. And then this is A. Oh, that works out because I'm solving for the apothem. It is A. Okay, so in this case, I know the opposite side, and I'm trying to find the adjacent side. Okay, so I know the opposite. I'm trying to find the adjacent. So that's tangent. So tangent of an angle equals O over A. So hopefully this is kind of coming back from when we studied trig. So here I'm going to plug in the information for my picture. So I have tangent of my angle, which is 36, equals O, which is 4, divided by the apothem, A. Okay. So here's where I have to go ahead and solve this. Okay, so this is going to be that two-step solution to solving. So here I would have to multiply by A to cancel my fraction. Okay, I have not solved for A yet. So I'm going to go ahead and just rewrite it down here. So A times the tangent of 36 equals 4. To solve that, I have to move tangent of 36 to the other side. I can do so by dividing. Tangent of 36 divided by tangent of 36. So I get A equals 4 over tangent of 36 degrees. Okay, just like that. So what I'm going to do is I'm going to keep it as 4 divided by tangent of 36 instead of like rounding it. That just makes it easier for me, and at the very end I will round. Okay, so I have 4 divided by tangent of 36 as the apothem here. Okay, so now all this stuff. Okay, so I can go ahead and plug into my area now. So I have area equals 1/2 parentheses 4 over tangent of 36, that's going to give me my apothem, times my side length. My entire side length is 8, and my number of sides is 5. Okay, so this is where I'm going to use my calculator. You can use Desmos or a calculator if you have it, and you need to make sure your mode is in degrees. Okay, so every time you use trig, you have to make sure your mode is in degrees. Okay, I'm just going to type 1/2 as 0.5. And then I'm going to do parentheses 4 divided by tangent of 36. Okay, so notice how I'm just keeping it just, I don't know if you can really see it. I'm just typing it in just like this, parentheses 8, parentheses 5. So I'm just putting parentheses around everything. And I get that my area is, I'm going to round to 2 decimal places, so 110.11. So I get that my area is approximately 110.11, and that was in inches, so it's inches squared. All right, so sometimes instead of special right, you're going to have to use trig. Okay, so you can just kind of keep that Post-it note with you, just in your notes. You can just kind of tuck it away, and then we will focus on the next one. Okay, so the next one's a regular septagon. Okay, I am not going to keep attempting to draw these because they're just going to get worse and worse. So a septagon has 7 sides. Okay, 7 sides. I don't want to attempt to draw a 7-sided figure that's the same. It's just not going to work. So instead, notice how we never really use the overall figure. We just use the triangle. So I'm going to start and just draw the triangle. So if I have a 7-sided figure, okay, I'm just going to draw that single triangle within the septagon, and I know that there's going to be 7 of those total that create the figure. Okay, all right. So I drew. So I'm kind of just starting on step 1. I drew the triangle. I know the apothem is 5, so I'm going to go ahead and add the apothem length. Is 5. Okay, just like that. So now I want to find the central angle. So here 1, I draw my triangle. 2, I'll just do down here. going to do my central angle. So that's going to be 360 degrees divided by n, which is 360 divided by 7. Ooh, that's not a nice one. Okay, 360 divided by 7 is 51.428. Right? Sometimes they're not going to be nice decimals. So I'm going to say that's approximately, I'm just going to say approximately 51.43. Okay, I want to keep, what just happened? Oh, sorry, something went out for a second. I want to keep some accuracy. I don't want to just do 51. So I'm going to do 51.43. Okay, so remember that's this overall angle right out here. So this overall angle is about 51.43. So what I'm going to do is I'm going to draw that right triangle that I'm going to use. Okay, so I'm going to highlight it. Okay, I'm going to draw the right triangle that I'm going to use right here. Okay, I'm going to divide that 51.43 in half. So divided by 2, I'm going to keep 2 decimal places, so 25.71. So I'm going to say this angle right here is 25.71. It's like kind of a nasty number. That's okay. And I know that this side length is 5, so I still have that this is 5. Okay, so that's what I have for my right triangle. So they're not always going to be nice values. That's okay. We're still just going to use what we know to help us solve. Okay. Then the third thing, right, is always to figure out what we need to solve for. So 1/2 ASN. So if I look at that, I know my apothem's length, right? It's 5. So I know the apothem. And you always know the number of sides. I know the number of sides is 7. What I don't know in this case is the side length. Okay. So right here, I'm going to use my little right triangle to solve for x here. And remember, these are both x, so I'm going to have to put them together to get the side length. Okay, so here, if I know those two values are both x, I basically have to find this value and double it to get the overall side length. Okay, so I'm going to do the same thing here. I'm going to use trig, okay, to solve this because it is not a special right triangle. I'm just going to go ahead and do this one on my notes. Okay, so I'm going to label my sides. So h is across from the hypotenuse, or is the hypotenuse that's across from the right angle. I'm going to do the opposite side, so opposite my angle is x, and adjacent is this 5. Okay. So in this case, I know my adjacent side, and I want to find the opposite side. Now, what you're going to come to find is that in 99% of these problems, you're going to use tangent because you're dealing with these two dimensions to find the area, which is like the base and the height, right? You're not dealing with the hypotenuse here. Okay, so 99% of the time, you're going to use tangent. So opposite and adjacent is tangent. So tangent of an angle equals O over A. I'm going to substitute what I know from this problem. So tangent, my angle is 25.71 equals opposite, which is x, right, over the adjacent, which is 5. Okay. All right. So to solve that, I need to get rid of the fraction. So it's being divided by 5. I would multiply by 5 to cancel. And notice how I get x by itself. So x is equal to 5 times the tangent of 25.71. Okay. Now remember, for the side length, I have to double that. Okay. So for the side, okay, because I just found one little part of it, for the side I have to do 2 times 5 times tangent of 25.71. Okay, now I'm just going to keep this in terms of the trig ratio until I plug it in at the end. So here I have 2 times 5 times tangent. So 2 times 5, I can make that 10 times tangent of 25.71 is the side length. Okay, so here I've got my side length there. So now I can plug everything into this formula, okay, because I've solved for what I needed. So here I'm going to have 1/2. My apothem is 5. My side length is 10 times the tangent of 25.71. and then the number of sides is 7. Okay, because remember this is one triangle, but there would be 7 that would create that septagon. Okay, I'm going to use my calculator to type that all in. Okay, so I'm going to do 0.5, and then I'm just going to use parentheses, parentheses 5, parentheses 10, tangent 25.71, parentheses 7. Okay, so here I'm getting my area to be 84.26 if I round to the hundreds. Okay, so I get the area is approximately 84.26, and this is in centimeters, so centimeters squared. Okay, so I know that these are a little complicated, but if you just stick with it and go step by step and use what you know from Unit 5, so in this case using trig to help you solve, last class was using special right triangles to help you solve. So you're going to have to use one or the other to help you solve for what you don't know until you can plug into this formula, which is ultimately finding the area of one triangle and multiplying it by the number of triangles there to find the overall area. Okay, we will continue to work on this in class, so stick with me.